Okay, 5.5a, college algebra, inverses of matrices. And so what we're going to do is we're going to look at the multiplicative inverse, or simply the inverse of a square matrix if it exists. And we're going to start out with the identity matrix. Alright, so far in math you know that any number times 1 equals itself. And that is the multiplicative identity. It just means that when we take a number times 1, we're going to get that number back. We get its identity there. Alright, so the identity matrix is when we have a square matrix. If we were to take the matrix, let's just call one matrix A, and we multiply it by its identity, which when we do it up here in simple math, it's just 1, and that's going to equal the identity times the matrix itself, which means it's going to equal A. So if we multiply A times its identity, or its identity times A, we're going to get, in both situations, what we started with, A. Just like here, if we took 8 times 1, we get 8, or 1 times 8, we get 8. But either way, we get its identity. So that's what we have here. Alright, so what do we do with that? Alright, so let's look at example 1. Now we've got a 2 by 2 matrix and a 2 by 2 identity. Has to be a 2 by 2, 3 by 3, 4 by 4. It has to be square, and it has to be the same. So a 2 by 2, 2 by 2. An identity matrix looks like this. The main diagonal has 1s, everything else is a 0. Okay, so if we were to do the multiplication here, this is from last section, remember, this is 2 by 2, and this is a 2 by 2. These two numbers have to be the same for us to be possible, and it's going to produce a 2 by 2 matrix. And we have this here, and we have a 2 by 2 matrix for our answer. And remember, in order to put numbers in there, we take the first row times the first column. So 4 times 1 plus negative 7 times 0 gives us a 4. And we do this one right here. It would be 4 times 0, 0. Negative 7 times 1 is negative 7. So what we end up getting is our A back here when we multiply it by its I. Now if we did the same thing with I times A, we have to get the same thing, or it's not an identity matrix, and it always will give us the same thing. So that's the identity matrix. The next section is the inverse of a matrix, and that's what we'll be spending more of our time with, because the inverse of a matrix is important when we're trying to solve systems of equations. So for a matrix that's square, 2 by 2, 3 by 3, 4 by 4, and we'll call this matrix A, and this is the gray box in the middle of 483. So for an n by n matrix, or a square matrix A, if there's another matrix, the inverse of A, for which, okay, so there's this matrix and there's this matrix, which is the inverse, so that if we multiply the inverse times A, we will get the identity matrix, which is going to be, depending on what size matrix we have, basically, that's a 3 by 3, and it's going to be the identity matrix. And that's also going to be the same as if we were to take A times the inverse of A. If this is a true statement, if the inverse times A equals identity, or if A times its inverse also equals the identity, then A to the negative 1 is the inverse of A. Alright? So this is A inverse, this is A. Alright, so let's look at example 2. Okay, so example 2 says verify that this is the inverse of this. So basically what we're trying to do is show that B is that, the inverse of that. Okay, so how do we do that? Well, we follow the instructions in the middle of page 483, and basically we take b times a, because if one is the inverse and the other, if b is the inverse of a, then if we multiply them together, we should get the identity matrix. And if we take a times b, we should also get the identity matrix. So we have to do both of those in order to find out if that's true. So let's do the b times a first and see what we get. So what we're going to do is we're going to take b times a, this b times this a, and when we do that, we have to get a 2 by 2 matrix that looks like that, the identity matrix, because b times a equals the identity if they are inverses of each other. So basically you do the same thing you did in the last section, where you, first of all, we get rid of those, because that's what we're going to fill in the blanks with. So this first blank is first row, first column. 4 times negative 2 is negative 8 plus 9 is 1. And this one here is going to be first row, second column. First row, second column. 12 plus negative 12 is 0. This one here, second row, first column. Second row, first column. Negative 6 and 6 is 0. And this one here is second row, second column. Second row, second column. 3 times 3 is 9. Negative 2 times 4 is negative 8. Gives us a 1. So yes, it works. Now we have to do backwards. Okay, 4, negative 3, 3, negative 2. Multiply that, and this time we get that again. So we can say that b is the inverse of a. Okay, so that was showing that one is the inverse of another, but what if we have that there and we want to find the inverse? Okay, that takes us to our next point. So here's the procedure to find the identity matrix, or I mean the inverse matrix. First of all, we write an augmented matrix. So we do this, line, and then we write our identity matrix, which is a 2 by 2 because this is a 2 by 2. Alright, so what our goal is to change this around and make these, basically put this over here. So this will be a 1, this will be a 1, this will be a 0, this will be a 0. So this goes back a couple lessons to where we tried to make this into a 1, 1, 0, 0. Okay? And then we don't care what this is, but when we're done, this is going to end up being our inverse. Alright, so let's get started here. Let's multiply this top row by negative 1/2. And when we do that, we get a positive 1, a negative 3/2, a negative 1/2, and a 0. And the bottom stays the same. Okay? So now we're trying to get this to be a 0 because it's under the 1. So what we're going to do is we're going to take 3 times this to make that a 3. We're going to add it to that and have a 0. Okay? So what we're going to do is we're going to multiply. Remember, when you're going to multiply this whole thing by 3, and that's not going to change this at all, but it'll change this. So let's write this as 3. So let's show what our new matrix is going to be. 1, negative 3 halves. Remember I said this won't change at all, but it changes while we solve to come up with a new bottom there. Alright, so this times this is 3. 3 minus 3 is 0. This times this is negative 9 halves plus 4 will be negative 1 half. This times this will be negative 3 halves plus 0. And this times this is 0 plus 1 is 1. Okay, so what did we do with all that? We made this into a 0 by multiplying this whole thing by 3, adding it to that, and then leaving this alone and writing down our new numbers once we add and get this. So let's go back up here and we'll continue on here. And we're going to change this to a 1 by multiplying the whole thing by a, let's see, negative 2. So what does that give me on the top? Nothing changed. In the bottom, that's a 0. This is a 1. This is a 3, and this is a negative 2. Okay, so now all we do is have to change this to a 0, and then we will be done. 1, 1, 0, 0. So we have to change that to a 0. So we're going to multiply the second row by 3 halves, so that when we add it to this, this turns into a 0. So let's multiply this by 3 halves. And remember that bottom row doesn't change. So let's go and rewrite this. Negative 1. Whoops, that's going to change. Okay, so let's multiply this times 0 and add that, and we get our 1. This times 1 is 3 halves plus negative 3 halves is 0. This times this is 9 halves. And this, whoops, I got to add that to the negative 1 half, so that would be a 4, wouldn't it? And then this here, negative 3 halves times negative 2 would just give me a negative 3. Okay, so I changed that all around, and this ends up being my inverse to this. Okay. Okay, so this is the end of 5.5a. We'll continue on with example 4 and go into example 5 then and be done.